In this problem, it is given that k is undistinguishable balls. There are k undistinguishable balls, and these are successively distributed, allocated into distinguishable urns of infinite capacity. Then the number of different distributions is. So it is given that there are n urns whose capacity is nothing but unlimited. So first, second, third, fourth, so on up to there are n urns, and the capacity of each urn is infinite. And k number of balls are there, and we have to distribute. In how many ways can we distribute these k balls into these n urns? Now, I can take all these balls and put them in urn 1, or I can distribute k balls into 2 urns, or I can distribute them into 3, or into 4, or into 5, and so on, or into n. So it is nothing but 1, 2, 3, 4, so on up to n. That is nothing but nc1, nc2, nc3, so on up to k. So this is nothing but sum of binomial coefficients, which is nothing but n plus k minus 1 c k, which is option D.
A graph is given and we have to find out the size of minimum vertex cover and maximum matching. Minimum vertex cover of a graph is nothing but minimum number of vertices taken from the given graph, such that each edge of the graph should be incident on at least one of the vertices in the minimum cover. So here if we take vertices x1, x4, let us take vertices x1, x4, y1 and y3. So here this is x1 and this is x4, this is y1, this is y4. So here on vertex x1, edges covered are x1, y1, so x1, y2, and on vertex x4 the edges covered are x1, y4, x4, y2 and x4, y5. From vertex y1, the edges covered will be y1, x3, y1, x2, y1, x4 and y1, x5. Here this is not y4, this is y3. So if you take vertex x4, the edges covered will be x4, y4. We should not take this edge x4, y3. There is no edge from x4 and y3. So this is not there. So if we take vertices x1, x4, y1 and y3, then all the edges of the graph are covered. So this is the minimum vertex cover. So the number of elements in minimum vertex cover is 4. Maximal matching is nothing but the maximum possible number of edges taken, such that degree of each vertex of the graph should be at most 1. So here if we take the edges x1, y2, x2, y1, x3, y3 and x4, y4, then the degree of each and every vertex of the given graph is at most 1. So here this is the maximum matching. The number of elements in the maximum matching is 1, 2, 3 and 4. So here both minimal vertex, size of minimum vertex cover and maximum matching is same, which is 4 comma 4. So here correct option is option C. In this question, a program is given. In this program, A is declared as integer variable, B is declared as float variable, and C is declared as character variable. And we have to find the output of this program. If we enter data item, if we enter 21 953.763 and S. Here format specifier for variable A is %3D. So here, and we have entered 21 for A. So here 21 will be displayed, and format specifier for B is %5F. %5F. So here, and we have entered 953.763. So here only 5 places will be displayed. So including decimal point. So here 953.7 will be displayed. And this 6 will be stored in C. So here 6 will be displayed. And these 3 and S are ignored. So here the output is this one. So here correct option is option D.